Okay, so multiplying and dividing with real numbers. And the main focus here will be integers. The table here at the top is going to tell you two positive numbers multiplied or divided will give you a positive. Two negative numbers multiplied and divided will also give you a positive. And if you have one of each, you get a negative number. Key thing there, and the signs are in the front of my room. Same sign, positive, different sign, negative. This is for multiplying and dividing only. So, negative 12 times 5, those have different signs, so our answer will be negative. And 12 times 5 is 60. Next, there's a substitution problem. 8x for x being negative 5/4. So this is 8 times negative 5/4. A lot of people are going to prefer to write this as 8 over 1 times negative 5/4. And there's nothing wrong with that. The one thing we want to remember when we have numbers like these is that we can simplify. Meaning, since 8 and 4 are on different levels of the fractions, I can make them go away. 4 goes into 4 one time, 4 goes into 8 twice. This makes our lives a lot easier. 2 times negative 5 is negative 10. And since both denominators are 1, 1 times 1 is 1, it does nothing. Were there any numbers other than 1 left in the denominator, we would have a fraction for an answer here. Division by a fraction. Let's remember we can't actually do that. So hopefully we remember that in order to divide, it's a two-step process, change the problem to multiplication and flip the second fraction. We change it to multiplication and flip the second fraction. Now, there's some canceling we can do here. In the previous problem, we saw 4 and 8 cancel to 1 and 2 respectively. But also here, 5 and 15 can cancel into 1 and 3 respectively. Now, we have negative times a negative, so that's positive. In the numerator, we have 1 times 3, which is 3. In the denominator, we have 1 times 2, which is 2. And in Algebra 1, you can absolutely leave that as 3 divided by 2. No need to change that to 1.5 or 1.5. I would actually prefer that you didn't. Leave it as 3 halves. The next problem is negative 4 divided by negative 9 1/4. So the negative 4 is fine. We know we can't divide by a fraction, so we're going to have to multiply by the reciprocal of this fraction, which will still be negative. But we can't just flip 9 1/4. We must change that into an improper fraction before we can flip it. So, to change to an improper fraction, you need to remember we have to multiply upwards, turn, and then add. So this fraction right here is the same thing as, negative 4 times 9 is 36, plus 1 is 37. Now we are flipping this because it was a division problem and I need it to be a multiplication problem. If it makes you feel better, you can absolutely put that first negative 4 over 1, and now you're multiplying. Negative 4 times negative 4 is positive 16. 1 times 37 is 37. And yes, we're going to leave that as it is. And what does 0 do to things? So substitution problems at the bottom here. We have 3x, but we're going to let x be 0. So this is 3 times 0. Of course, anything times 0 is 0. Next, we have d divided by 4 for d being 0. So we'll put 0 in for d. We have 0 divided by 4. And if you have nothing and divide it amongst your 4 friends, you all have nothing. 0 divided by anything is 0. And last we have 5 divided by A, for A being played by 0. This is the trick. You cannot divide by 0. You get, on most of your calculators, it might say divide by 0 error. It might say undefined. We want to say undefined. You cannot divide something into 0 parts. So 5 divided by 0 is undefined.